In today's lesson, we are going to talk about section 5-6, the quadratic formula and the discriminant, part 1. So today's lesson, we will focus on the discriminant part of the quadratic formula. All right, so first we got to just understand what the quadratic formula is. So the quadratic formula is the solutions to the quadratic equation from the form ax squared plus bx plus c equals 0 when a is not equal to 0. And the quadratic formula would be x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. You can sing this to the song Pop Goes the Weasel, but I will not because I cannot sing very well. So what we're going to focus on, like I just said at the beginning of the video, is the discriminant. Right there in red, as you can see, is the b squared minus 4ac. Now, when we solve this b squared minus 4ac part, it can tell us of some different things. So when we're considering the discriminant, if it is greater than 0, if the discriminant is greater than 0, the answers are going to be real. We'll have two real numbers, and the answers will be rational if the discriminant is a perfect square. So perfect squares 1, 4, 9, 16, 25, and so on. If b squared minus 4ac, or the discriminant, is greater than 0 and not a perfect square, we'll have two real irrational roots. If the discriminant is equal to 0, we'll have one rational root. And if it is less than 0, we'll have two complex roots, or imaginary numbers in there. Okay, so this is what we're going to determine when we look through the discriminant. So find the value of the discriminant for each quadratic equation, then describe the number and type of roots for the equation. So we have 9x squared minus 12x plus 4 is equal to 0. So given that our quadratic formula is already equal to 0, we can apply the quadratic formula, but we're just going to focus on the discriminant. So we have, now I'm just going to rewrite this, b squared minus 4ac. So here, I'm going to label this, we have our a, we have b, and then we have c. So b squared, so it's negative 12. So negative 12 squared minus 4 times a, which is 9, times c, which is 4. So now we just need to simplify. So negative 12 squared is 144 minus 4 times 9 times 4. I believe that should be 144 also. And when we subtract that, we get 0. So given that we have a discriminant of 0, that means how many roots will we have? We'd have one rational root. All right. So keep in mind, I'm thinking back to this chart, and if we have right here equals 0, that means we have one real rational root. So that's what I'm looking at right there. All right, so there is my two answers. So let's do the next one. 2x squared minus 16x plus 33. So again, I'm going to write this out. So we have b squared minus 4ac. So we have a, b, and c. So let's just 16 squared minus 4 times a, which is 2, times c, which is 33. Okay, so 16 squared, that would be 256. And then minus, a little scratch work here. 2 times 4 is 8, and you multiply by 33. 4, carry the 2, Again, 24 plus 264. And then we subtract, so we get a negative 8. So our value of the discriminant is negative 8. And if we get negative 8, looking back, if we have a negative answer less than 0, that means we have 2 complex roots. Oh, wrong way. So that means we have the type, we have 2 complex roots. Okay, so that's using the discriminant to identify what kind of answers we will be having when we finish the quadratic formula.